So we've talked about vectors in 3 dimensions for a little while, and now we're actually going to change gears a little bit and say, well, what happens if I describe the z-coordinate in terms of some function of x and y? What type of object should that be? So one thing that I want you to recall in a function of a single variable, so what would we write there? Something like y equals f of x. The way that we would interpret this is if you give me an x, the function y assigns a height to each input x. So if we just sketch something pretty quickly, I could pick an x here. The function would give me a y value. I could pick another x here. The function would give me a different one. One here. I mean, you can do this, and when you do that for all of the different inputs, you get a curve. So bearing that in mind, let's try to study what type of object is described by this new relationship, z equals f of xy, in the context of a specific example. Okay, so let's look at this particular example. Here we have z is equal to 12 plus x squared plus y cubed minus 3 sine of xy. So what should this represent? Well, if we think about how we treated functions of a single variable, we want to study what happens for each input. And now our inputs, there are actually 2 of them, both x and y. So if I pick an x and a y, let's say, for instance, I pick this point right here, where x is equal to 1 and y is equal to -1. So in the xy plane shown, I can plug that value into this function, and I can get a height. So you can do that on your own if you'd like, but what that's going to tell me is that this thing is going to go up a little bit, and this will be my z. Right here. So there's a particular height associated to that point. Now, we don't just have to use that point. We could, for instance, try other ones. So we could look here where x is equal to 0 and y is -1. Plug into the function. We can get a height. Takes me to about there. We can do it for more points. Plug these into the function. And what we really can do is we can do this for every point in the xy plane. And when we do that, what kind of object are we going to get? Well, let's see. So this is pretty cool. Now, when we do this for all of the points, we actually get this really curvy object. And that really is, it's a surface. So we no longer have just a curve. We actually have a surface where to every point in the xy plane, there is an associated height. So just a little comment, I sort of think that fading technology is pretty cool. We've been playing with that recently. So
This is best to spend all semester.
Very funny. Let's get back to some math.